All right, so I'm recording it. So once again, you got any questions, just let me know. But we're just going to look at how to come up with the slope of the tangent line or an equation of the tangent line. So I'm going to do number 5. Once again, you can try this, pause it if you want, or just try it on your own. Make sure you get the same thing. But anyway, we've got y equals x cubed plus 3. Well, we know, and we're looking at the point 1, 4. So we know what this graph looks like. I mean, this is really, we could call that f of x, but it's an upshift 3 units, right, of the x cubed graph. So over at 1, I'm up at 4, right? And so basically, I'm going to use a different color here. And so I'm looking for the slope of this tangent line. And actually, I think this is actually said find an equation of the tangent line at that point. So we want an equation of the red tangent line at the point 1, 4 there. So with that being said, we need to find the slope of the tangent line. And once again, you can either do it at x sub 1 equals 1, or we can actually do it in general and then plug in 1. So what I might do is I might do it in general and then plug that in. So we know that the slope of the tangent line at any point x, we says a limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And so that once again, this is just finding the slope of the tangent line. And then after we find that, we're going to be able to say, hey, the equation of the equation of the tangent line is going to be y minus y1 equals the slope, which is actually going to be the slope of the tangent line, times x minus x1, is the easiest way, where this answer we're just going to plug in right there. And then my x1, y1 is actually up here at 1 and 4. So that's x1, y1. So we can plug in 1 here, and we can plug in 4 here. So let me clear this so we get a little, whoa, I just stopped that. I didn't mean to stop that. Okay, clear it, start again. And so once again, so the slope of the tangent line is what we're trying to find out here. But the first thing that we need to do is let's find out what f of x plus h is. That's the first one. Well, that's f evaluated at x plus h. So if we've got f of x equals x cubed plus 3, right? So this is going to be x plus h. So f of anything is that anything cubed plus 3. So it's x plus h quantity cubed, then plus 3. So I'm plugging in the x plus h everywhere I see an x. So there's only one place I see an x here. But really, I got to cube this out now. So when I cube this out, I need to know what x plus h cubed is. So what I can do is I can square it out first, and then multiply that by x plus h. So if I square it out first, this part right here is x squared plus 2hx plus h squared, right? And then I'm going to multiply that times x plus h. So really what I'm going to do here is I'm going to take x times each part, and then I'm going to take plus h times each part. So I'm just going to use the distributive law twice. Really, that's what the FOIL method is using the distributive law twice. Well, that's what I'm going to do here too when I'm taking x plus h times this trinomial. And when I do that, I'll try and keep with my color scheme here. But x times x squared, that's going to be x cubed. And then x times plus 2h is plus 2hx. And I usually keep it in alphabet, it's x times 2hx, so it's x squared. There's two x's there, right? X times x. And then plus h squared times x is h squared x. I usually keep my variables in alphabetical order, but that's for the purple one. And then now if I go to the green one, so plus h times all that is plus hx squared plus 2h squared x, and then plus h cubed. And then what I want to do is I want to multiply or combine like terms, right? So let's just put this back in blue. But I've got an x cubed that's by itself. So this is x cubed. And then I've got plus 2hx squared, and plus hx squared is plus 3hx squared. So that's an h. And then I've got plus h squared x plus 2h squared x is plus 3h squared x. And then I've got my plus h cubed. Okay, and that's just for the first part, x plus h quantity cubed, and then I still have the plus 3 there, right? So then I put plus 3 on there as well. So that's f of x plus h, and then we have minus f of x, and then all over h. I didn't really follow my formula, did I? Because what did I put on the previous page? Instead of h, sorry, I was using delta x, wasn't I? And that's fine. We can just make all of those delta x's, but you got to be a little bit careful because it's delta x times x squared and delta x squared times x, right, on all these. So it's delta x times x squared. So let me clear all this crud and rewrite it using delta x's. So the slope of the tangent line at any point x is going to be the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. All right, so that was kind of the base formula that the book has. And then what I did on the other page there in blue was this one. And anyway, so let's go ahead and write that in. So this is the limit as delta x approaches 0. So that's going to be the last thing that we do. But in blue, what I had just done on the previous screen, I should be able to remember, but it's x cubed plus 3x squared delta x plus 3 excuse me, x delta x. It doesn't matter which one's first, but x delta x squared or 3 delta x squared times x, and then plus delta x cubed. So instead of the h cubed, and then plus 3, right? So that was the blue, is actually this part right here that we got on the previous page. And then minus f of x is all in the numerator, but I'm kind of out of room on my screen. So I'm going to put minus f of x. Well, what is f of x? F of x is x cubed plus 3, right? And then that's all over delta x. Okay, so and then of course, what do we do here? We're going to add the opposite. So we're going to add the opposite of those things. So what happens is the 3 and the minus 3 cancel, the x cubed and the minus cubed cancel. And so really all I'm left with is this stuff on top, and I'm left with a delta x on the bottom. So then what I can do is factor out a delta x on everything on top. And so if I do that, so now I'm going to have the limit as delta x approaches 0. So once again, I haven't done that yet. But I'm going to factor out a delta x on top, and I'm left with 3x squared plus 3x, plus 3x. And then times delta x, right? So I still have, because that was delta x squared, so I still have a delta x for that one. And then plus delta x squared. And then all over delta x. So now, very similarly, this is multiplication, so these delta x's cancel because delta x doesn't equal 0. And I'll be left with just this part right here. So 3x squared plus 3x delta x plus delta x squared. And then now, so now I can say let delta x go to 0. And if I let delta x go to 0, what do I get? Well, I'm just going to get 3x squared, right? Because this thing would go to 0 and this thing would go to 0. because of it's a polynomial, right? So I could just plug it in. So I'm going to end up with 3x squared. So the slope of the tangent line at any point x is going to be 3x squared. If you would have done it for x sub 1 equals 1, all these x's would have been a 1. So like all of these would have been a 1 here. So what I did is I did it in general and got 3x squared. If you did it for x equals 1, x sub 1 equals 1, you would have got 3 times 1 squared, which is just 3. So anyway, so the slope of the tangent line at x sub 1, I'm going to plug in here, is equal to 3. Let me clear this off and go back. So now I can say the slope of the tangent line at x equals 1 is 3 times 1 squared, which is 3. And that wasn't, it wanted the equation of the tangent line, and there's two different ways I can do this. So one is a point slope form. I have a point because the point is 1, 4. So I have a point and I have the slope, so I can use point slope form of line. So y minus y1 is the slope, really the slope of the tangent line, because that's what it is, times x minus x1. So y minus 4, because this is my y1, and this is my x1, is the slope of the tangent line, which is 3 times x minus x1, which is 1. Now, this is actually an answer that's good enough for your homework to turn in, because if I say, give me an equation of the tangent line, this is an equation of the tangent line. It happens to be in point slope form. However, if you look at the back of the book, you will not agree with this answer because what are they going to do? They wrote their answer in slope intercept form. So what they did is they say, hey, this is 3x minus 3 on the right. So we got y minus 4 equals 3x minus 3. And then they're going to add 4 to both sides. And they're going to have the answer, the equation of the tangent line is y equals 3x plus 1. So this is the answer that they have. Both are correct. As long as you simplify it, just know that for me, you know, I answered the question, so I'm going to use the easiest version of the formula. So let's say that, as we notice, we don't remember everything in algebra, and let's say that the only equation that you actually remembered was y equals mx plus b. The question is, could I still come up with the correct answer or a correct answer by only knowing that formula? And the answer is yes, because I know what the slope is. The slope is 3, right? So I could rewrite that as y equals 3x plus b. But the thing is, I don't know what b is, do I? But I could plug in a particular point. Once again, here's my x and here's my y. So instead of x1, y1, I could just consider that xy. And y, I could put in 4 equals 3 times x. X is 1 plus b. And if I solve this, I get that 1 equals b. And then plug that back in right here. And notice that that gives me the same exact equation, y equals 3x plus 1. So if all you knew is the y equals mx plus b formula, we could also do it. Okay, so any questions on that? Doesn't sound like it. So what I'm going to do, I'm going to clear this off, and I'm going to go back, and I'm going to show if you would have done this same problem. So once again, we've got, you know, f of x equals x cubed plus 3. If I want to find the slope of the tangent line at a particular x sub 1 equals 1, and then I'm going to say that's the limit as delta x approaches 0 of f of x1 plus delta x, if I actually plug in the specific x1 that I have, minus f of x1, that'd be minus f of 1, all over delta x. This is actually what the difference quotient would be just for that particular x, because we wanted to find it when x1 equals 4, or x1 equals 1, and the height is 4, right? So anyway, I could do this. We need to find out what f of x, f of 1 plus delta x is. Well, once again, f of anything is at anything cubed. I'm sorry, that wasn't the problem, was it? It was plus 3. I remembered my problem wrong. Trying to remember the answer of the, it was the equation of the tangent line was a little bit different. That had a +1. But anyway, so this was my original function here, right? I think, let me look back. Yep, x cubed plus 3. So if I want f of 1 plus delta x, I plug in 1 plus delta x everywhere there's an x. So it's 1 plus delta x quantity cubed, and then plus 3, right? So that's this one. And then minus f of 1. Okay, well, what's f of 1? If I plug in 1, I get 1 cubed plus 3, which is 4. But actually, I already knew that f of 1 equals 4 right there, right? And then all over delta x. Okay, but I'm going to go ahead and cube this blue one out. So let's cube that out. So 1 plus delta x quantity cubed is 1 plus delta x times 1 plus delta x quantity squared. So it's going to be 1 plus delta x times, and if I square this out, the FOIL becomes the fool. So it's 1 squared, which is 1, plus multiply these two and double it. So that's 2 delta x, plus the last one squared. We got that. Whoops, I forgot my delta x there. And then what am I going to do? I'm going to use the distributive law twice, right? So I'm going to multiply 1 times each part, and then I'm going to multiply the plus x times each part. So doing that, multiplying 1 times each part, I get 1 plus 2 delta x plus delta x squared, multiplying 1 through there. And if I multiply a delta x through there, I get plus delta x, and then plus 2 delta x squared, and then plus delta x cubed. And that would be what I get inside. I use purple, but that's actually what's in the blue box. Oh, and then plus 3 though, right? I got to have, that's cubed, and then plus 3 was still in there, right? So now what do we notice? So if I replace that up here and get rid of that, it's equivalent to what I have in the blue box here. But notice what cancels on top. I've got, let me use orange for what cancels. 1 and 3 is 4, and that cancels with that 4. And then I've got a bunch of stuff that has delta x's in it. Some of this would actually simplify, right? So on top, I'm going to have 2 delta x plus another delta x is 3 delta x, right? That's this one and this one. So those are gone now. And then I've got plus delta x squared and plus 2 delta x squared is plus 3 delta x squared. So those are gone. And then I've got plus delta x cubed, right? And that's that one. And then that's all over delta x. Well, then I could pull a delta x out of the top. And if I do that, pull out a delta x, I'm going to get 3 plus 3 delta x plus delta x squared, right? Instead of that. And then what can I do now? I can cancel these delta x's, and I'll be left with 3 plus 3 delta x plus delta x squared. And then now, let me rewrite that, hopefully. So I have 3 plus 3 delta x plus delta x squared. And then I want to take the limit as delta x approaches 0, right, of that thing. And so if I do that, then I can just go ahead and, whoops, I can go ahead and let delta x go to 0. That's going to go to 0, and that's going to go to 0, and that equals 3. So once again, what was that? That was the slope of the tangent line at x sub 1 equals 1, right, is 3. And then once again, y minus y1 equals slope of the tangent line times x minus x1. And we fill in just like we did before. So that's a 3. We had x minus 1 and y minus 4. Whoops, y minus 4 over here. Anyway, and that simplifies also to y equals 3x plus 1 for the equation of the tangent line. So I could have done it either way. You can use dealer's choice on that. If you have a particular point, you can plug in the particular point, but I'm going to normally do it the version of the first way, and that's doing it in general for any x and then plugging in my specific point, because the next question might be, hey, what would the equation of the tangent line be at x equals 2? Well, if I did it the second way, I'd have to do this whole process all over again to get something different. But if I already did it in general for the slope of the tangent line, instead of plugging in 1, I can just plug in 2. So hopefully that makes sense. So I guess any other questions on that? Don't think so. So let me just, and I'm not going to do this whole problem, but like on number 9, I just want to mention this. So we have, I mean, if you're going to work this out, this is probably going to take a little time. We've got f of x equals x cubed minus 6x squared plus 9x minus 2. And if I want the slope of the tangent line at any point x, well, that's the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x, right? And so once again, if I am looking at this one and I plug in an x plus delta x everywhere there's an x, well, there's a whole lot of places that there's an x here. So what would that be? So I'll just look at this part. It's f of x plus delta x would be x plus delta x quantity cubed minus 6 times x plus delta x quantity squared plus 9 times x plus delta x, and then minus 2. And that is what's in the box here for the f of x plus delta x. And of course, you know, this is a lot. We already did this one, so it's x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed plus delta x cubed. And then here, this part, when you square it, is x squared plus 2x delta x plus delta x squared instead of that. And then I got to take minus 6 times that. So it'd be minus 6x squared minus 12x delta x plus, or minus 6 delta x squared, right? And then I can take the plus 9 times that, so plus 9x plus 9 delta x, just using the distributive law on the plus 9 times each part here, and then minus 2. So that whole thing in the box becomes this, and then you can try and combine like terms, etc. But that's a whole lot more shaking going on, because there were multiple places that we had an x where we needed to plug in an x plus delta x into those. And then don't forget, after you simplify what's in the blue box, minus f of x is actually minus all of this. So we will get stuff to cancel out, like the x cubes will cancel, the 6x squareds I thought were going to cancel, but anyway, I'm subtracting this whole thing, so I'm going to add the opposite of that, and then lots of stuff cancels. The 9x, the 6x squareds, and the 2's, those will all cancel with these up here. And so what's left in this blue box down here is what we're going to have left in the numerator, and then it's all over delta x, and then we pull out a delta x, get it to cancel, and see what's left. Long story short, when you do this, your answer should be the slope of the tangent line at any point x should end up being 3x squared minus 12x plus 9 without having it factored. That's at any point x. Anyway, but this is using the difference quotient. So that one gets a little lengthy, a little messy, so I understand that. And then the last thing I'm going to show you is there is a thing called Pascal's triangle, because you might say, okay, now I know how to do it for something squared. I FOIL it out, quantity squared. I know how to do it for something cubed. But what if I said, hey, I've got you know, f of x equals x to the fifth power. Well, then your f of x plus h is x plus h quantity to the fifth power. Well, you got a whole lot of multiplying going on, right? And what if I say to the 50th power? Well, we got to multiply out 50 different binomials. That takes a ton of time, right? You probably would just say, well, forget it, I'm just not going to do it. But there is a thing called Pascal's triangle that tells you how to do it. So if you put ones together and then add these two together, we get 2. Add these two together, we get 3. That gives you the coefficients. And so let me start over, write this a little bit smaller. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And really along this, and I didn't stay, this is the degree. So this would be like x plus y to the nth power, where n is given by these numbers. So this row right here is the coefficient. So 1, 5, 10, 10, 5, 1 is the coefficient of x plus y to the nth power. So if I have x plus y to the fifth power, then the coefficient on the first one is 1 right here. And then x gets all of that power, so times x to the fifth. And then y gets none of that power, so y to the 0. Of course, y to the 0 equals 1, right? So that part right there is just equal to 1 times x to the fifth, or just x to the fifth. And then plus, now the coefficient on the next one is a 5. And then x gets, the first term gets 1 less of those. So plus 5, x to the fourth. And then y gets 1, the second one, which is plus y, gets 1 more. So we decrease the 5 by 1 and we increase the 0 by 1. So this becomes x to the fifth plus 5, x to the fourth, y to the first, or just y. And then the next coefficient is 10. So plus 10, x gets 1 less, so x cubed, y gets 1 more, so y squared. So that's plus 10 x cubed y squared. And then the next one is a 10, so plus 10, x gets 1 less, so x squared, y gets 1 more in the power, so y cubed. So that's plus 10x squared y cubed. And then 5, so plus 5, x gets 1 less, so x to the first, y gets 1 more. Of course, x to the first is just x. So it's plus 5x y to the fourth. And then plus the last one is plus 1. And once again, plus 1, what? X to the 0, y to the fifth. But y to the 0 is 1. So this is just plus y to the fifth. So here is x plus y to the fifth power would be this. Now, we were using x plus delta x. So instead of y, it was delta x. So everywhere there's a y here, that would just be delta x to the first, delta x squared, delta x cubed, delta x to the fourth, and delta x to the fifth instead of the y. So we have a way to do that. And last but not least, if you have a minus sign in there, then the signs alternate. So first one's positive, then it'd be negative, positive, negative, positive, negative. I think I did that right. To the fifth power, yeah, because minus delta x quantity to the fifth would be a minus delta x to the fifth power. Anyway, so there you go. Pascal's triangle. If you've never heard of it,